The 5-number summary is a very useful measure of the variability within a dataset. It has the advantage of being quick and easy to calculate, while giving us an accurate picture of the spread of our data. As you might gather from the name, the 5-number summary consists of 5 numbers that summarize the dataset. The 5 numbers are minimum, quartile 1, median, quartile 3, and maximum. The minimum is the smallest number in the dataset. The maximum is the largest number in the dataset. The median is calculated using a median split as we have done before. Quartile 1 is the first quartile, aka the 25th percentile, the middle of the scores between the minimum and the median. Quartile 3 is the third quartile, also called the 75th percentile. It's the middle of the scores between the median and the maximum. Using dataset D and what we have just learned about the interquartile range, we can see that the minimum is 1. Quartile 1 is 3. The median is 3.5. Quartile 3 is 9. And the maximum is 20. We can see that the outlier affects the range, but not the interquartile range. If you are particularly clever, you may recognize that the 5-number summary gives you the same information as a box plot. The box plot is the graphic representation of the 5-number summary. Using the dataset world95.sav, we will now create the 5-number summary and a box plot using SPSS. The dataset world95.sav is demographic data from around the world from the year 1995. To begin our analysis, we will go to Analyze, Descriptive Statistics, Frequencies. We currently see our variables as variable names. To change that, right-click, or on a Mac, Control-click on any of the variable names and choose Display Variable Labels. We are interested in the variables average female life expectancy and average male life expectancy. Drag those into the variables box. Now click on Statistics. In order to calculate a 5-number summary, we will need the minimums, the maximum, quartiles, and the median. Actually, we don't need to choose the median. It is the same as quartile 2, but I want to prove that to you. So click Continue. Now unclick Display Frequency Tables and click OK. Before we spend too much time with the output, however, let's also create a box plot. Go to Graphs, Chart Builder. In the gallery, choose Box Plot. Drag Simple Box Plot up into the canvas. Move Average Female Life Expectancy into the Y-axis drop zone. And now click OK. There's our box plot. Alternately, we could create a box plot using the Explore command. So go to Analyze, Descriptive Statistics, Explore. Move Average Female Life Expectancy and Average Male Life Expectancy into the dependent list and click on Plots. Check Normality Plots with Tests and unclick Stem and Leaf. Click Continue and OK. Scroll down a little more and there's another box plot. Using the output from SPSS, let's create the 5-number summary. First of all, notice that the quartiles are actually listed as percentiles. The 25th percentile is the same as the first quartile. The 75th percentile is the third quartile. So continuing with our 5-number summary, the minimum is 43, the first quartile is 66.5, and the median is 74. Notice that the median is the same as the second quartile. The third quartile is 78, and the maximum is 82. So the 5-number summary for female life expectancy is 43, 66.5, 74, 78, 82. To reinforce the idea that we can display our data as numbers or pictures, let's look at the box plot. I've edited this a little bit to fit on the slide, but you can see that the minimum, maximum, and the lines of the box match the numbers of our 5-number summary. From this output, we can tell that in half of countries for 1995, female life expectancy was 74. The upper 50% of countries were between 74 and 82 years, an 8-year gap indicating that life expectancy is reaching its maximum. In the lower half of the distribution, there is much more variability. In the lowest quartile, the bottom whisker of the box plot, some countries have life expectancies between ages 43 and 66.5. This suggests that female life expectancy is unnaturally brief in a handful of countries. We could look at our data set to find out what countries those are. But now it's your turn. Create a box plot and a 5-number summary for average male life expectancy. Do some comparisons with what you find from average female life expectancy. Are the life expectancies similar or different? Who lives longer on average? And if you do it right, your answer will look like this.